Hello and welcome back to another quarantine vlog with me, John Grimsmo. The goal of today is to mount a face mill in the kern, that one. 3-flute Kyocera face mill. Mount that up, get it dialed in. I want to see what it can do. I need to face 4 sides of this fixture, and the goal, maybe not today, but maybe by tomorrow, is to mount blades, soft blades, raw blade blanks onto one face of this. So I got a drill, I got a thread mill, I got to prep this side of the fixture, and I got to make a top clamp to be able to hold on to the blades. So that's what the plan is for today. Pretty focused. I really got to get back to the Tornos. I got lots of parts to make. Maybe not today though. Alrighty, so we have the Kyocera face mill mounted in a PG25 holder. I got that all tightened up. Now we're going to put some inserts in it. I guess it's not really a face mill. It's more of like an inserted end mill, but I'm calling it a face mill. So I've got 2 kinds of inserts that I bought for this tool. These ones are for aluminum, and these ones are for steel or anything else. Oh, that one's already open. Okay. So they are different. You'll notice that these ones are super shiny, and I'm pretty sure they're black DLC coated. Yeah, they are coated. And these ones are a lot duller. Have a different kind of coating for steel. Steel or titanium or any of the harder stuff, basically. Also, these ones are a molded insert. I can tell by looking at the sharpness of the edge. They're decent. They're fairly sharp, but I'm pretty sure they're not a ground insert. Whereas these ones, oh yeah, they're beautiful. You can actually see the, get in focus here. You can actually see the grinding lines on the outside. That's kind of beautiful. So they do that to make a very sharp uprake and have a very sharp tool. You get better tolerances, better accuracy on the insert itself, and then better finishes on the part. Versus this guy being a molded insert. Also, check this out. I just noticed the ones for aluminum are single-sided. Nothing to do on the other side. The ones for steel are double-sided. So we get, it's kind of like an oblong insert. You get 1 cutting edge, 2 cutting edge, 3 and 4. So you get 4 out of here and only 2 out of that one. That's neat. So obviously we're going to be mounting these ones because I'm not cutting aluminum. Anyway, so grab my Torx Plus insert wrench right there, put the aluminum ones away. Torx Plus is really cool. You know, Torx is your typical star shape. Torx Plus is, it's like, actually I got a picture for you, hold on. Kyocera sent a really nice instruction manual with their stuff. So check this out. Torx is like a star shape. Torx Plus has these flats, these extra little bits, which makes it stronger. So obviously they sell it in both kinds depending on what they're promoting, what they're making, what they're selling. Everyone also comes with this anti-seize stuff. But I've got a tube of it right here that I'm going to use instead. Put some on the screw and on the taper. I noticed the bit driver was actually magnetic on purpose. It says so in the manual. Take an insert, make sure everything's clean. The insert pocket, this is kind of cool too. The insert pocket actually has like a pyramid, like a dome sticking up, because so that it can hold these weird shaped inserts. Because there's no flat back. so it kind of hugs in there. That's kind of cool. So it's seating on the inner area of the insert. I don't have a torquing wrench for this size, for a Torx Plus T8, or i8 IP8, whatever it's called. I don't have that yet, so I'm just guessing right now how tight to make these things. But yeah. Alright. This. So you'll probably notice my pen tattoo that I put on last night. It's Newton's second law of motion. Force equals mass times acceleration. I read it in a business book last night and they applied it to business, and I just really liked that quote, so I thought I'd write it down for a couple days and remember it. So at the end of the last video, I never did actually get to bolting these two together. So let's do that right now real quick. We have a steel fixture and we have a steel pallet. So they could corrode, rust over time. We're in a wet environment. Coolant's usually pretty oily, but you never know. So there's a lot of different ways to rust prevent this. There's Molly D, there's all kinds of rust inhibitors and things like that. I'm going to use a trick that my buddy told me that he uses at the big shop that he works at. They just take undiluted coolant and they put it between the two surfaces and they clamp it down. And he says he's never had rusting problems. So I've got a little bit here, and I'm just going to evenly do that. And then for the threads, for the M10 screws that I'm going to use a thread anti-seize, similar to the stuff we just put on the Kyocera inserts, but it's just another little tube that I had kicking around. So I don't want too much, but I don't want nothing. Woo, baby. It's good. Tighten it down and load it up. Alright, so let's check the 3 insert pockets on this tool. So here I have a Noga magnetic base on an articulating arm. These things are epic. If you don't have one of these yet and you're doing this kind of stuff, machine stuff, you need one. Mitutoyo 1/10 indicator. Dial test indicator, okay? So I've got it perfectly aligned at the high spot of the tool. If I go and rotate, see I'm rotating the tool. Oh, I think I bumped it. Alright, now I have unbumped it. So the goal here, as you can see, we're trying to get the high spot on the indicator. Going to 0 is not necessarily the goal. We're just comparing the 3 with each other. So that's as close as I could get to 0 without going crazy. So that's plus 1/10. Rotating to the next insert. Next one is plus 5/10, so that's 4/10 higher. And then this one is plus 2-ish. So they're not all identical. And I think I've heard and experienced, to keep consistent results, you only want to spin the same way. You don't want to go back and forth a couple times. I mean, it's easy to do that, so I'm not too concerned about it, but yeah, so there we have a +1, we have a +5, and then we have a too fast, +2. So two of them are almost exactly the same. One of them is higher than the other, so that high insert is going to leave a streak. So we'll run it and see. I guess I could pull that insert out, flip it over, put it back in, see how close we get. We'll see. So I went ahead and flipped it over, and that made it worse. So now it's all the way up to +1. Whereas the next one is +3-ish. So like I was saying earlier, these these molded inserts are not the most accurate thing in the world. Ground inserts have a more accurate profile. I played with it for another few minutes and I got them all within about 1.5 10,000ths of an inch. Very, very, very happy with that. The robot is ready. So I got our big honker mounted there in pallet position number 9. The one on the machine is pallet position number 12. Got to make sure that I don't put something where that's going to go. So that's going to go there. I've got mine there. All right, let's do this. Let's call pallet position number 9, MDI, workpiece, over, 9, and cycle start. Let's see. What did I miss? I feel like I missed something. Oh, feed rate's down at 0. There we go. I love how it goes ever so gently. Yes. Now you can see I've only got a couple inches up top there, but it doesn't lift it very high. Yeah, that's good. That's good, that's good. Coming through, yeah, we're good. Oh, yes. It is on. Good night door. Rotate the C-axis. Awesome. Okay. Crank open the door. Notice how I got it at a 45. That just helped with the bolt locations. I couldn't really do it well the other way. The machine's not going to care because in reality I'm just gonna run it like this. So this is what we're looking at here. This is how we're going to run parts. One side, two side, three side. Oh, yes! So I think I said in a previous vlog, this one has 1/2 inch thick, walls. The next ones I make are going to have, or these are 3/4. The next ones are going to be 1/2 inch. This sucker's heavy and I can take a lot of weight out without taking much strength out, I think. So I'm just going to, it's heavier than it needs to be, but good to learn for the next time. So on the top here, a center pallet, a chunk of steel is going to go there. And I have done my calculations to find the center point of weight balance, so that I want it even loaded up, fully loaded with parts and everything. I want it to be able to fling around at full RPM and be balanced. So this is what's happening. Not so much the knife. Don't forget it, John. But this is one of our blade blanks. It is water jet cut, and it has been double disc ground, and this one's actually been lapped. This is from, you know, 3-4 years ago, back when we did that and we sent out for lapping. Now we do all the lapping right there on that lapping machine. Lapping gives you a beautiful, like, smooth finish. Gets out all the scratches. This is lapped different than we do it. This is like a duller finish. But anyway, one blade is going to mount there. I could easily fit two, but this is a one blade tombstone. Like one knife tombstone. So handles are going to go on the other side and stuff. I just don't need two blades on here. There's no reason. So I got to figure out exactly. I haven't even fully designed this yet. So I'll be spending some time doing that right now. But essentially 2 screws are going to go there. And there's going to be a clamp here that goes slap and holds the blade. And I'll show you. This is kind of here's some older blades from years ago. Maybe I'll go on white. Before and after. So we're not touching this edge. We're not touching the hole. But we are touching, putting a radius here. This guy's already been through heat treat, that's why it's kind of powdery. We're cutting that off, we're putting a radius, we're putting the 2 jimping lines there. We're 3D machining the lock face. We're precision milling out the stop pin arc. The pivot hole has to be the perfect size. detent hole. And then we're profiling around the outside all the way to the front there. Not a ton of work, and then we're chamfering the top and the bottom of the hole in the slot. And then after it goes through heat treat, then it goes back on the machine. It'll go on another side of the fixture, and then the bevels will get cut, and then the engraving, Rask number 328 or whatever the next one is, will get put on there. And then, sorry, directly after heat treat, they go to lapping, and then they're gonna get all prettified, get all beautied. Like, I bet you I could find some Norsemen. No, not those. I think we've lapped them all, or we've run them all. They're in there somewhere. But you can kind of see, it's all locked and off right now, so I'm not going to open it. But that clamp right there is what we need to make. And old Rask fixture. I know you're here somewhere. Where'd you go, old Rask fixture? Oh, down there at the bottom. This is how we did it before. So here's how we did it, and it's going to be similar-ish. I'm going to use a thicker clamp because I found that helped. This is 1018, like mild steel, garbage. Going to make the new clamp out of 4140 and make it thicker. That's what we did for the Norseman. Made it a lot better. So because I only need one blade, fun fact, there's two blades here that I can steal and run. Since I only need one blade, I need to delete this side, and I need to have this side sitting on the fixture so it doesn't, you know, cantilever down or whatever. So I got to design it for that. And yeah, this kind of fixturing gives us full access to everything we need. And then the tab gets cut off, zip, 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 zip. And then this one gets cut off after we need it for support later. So that's why that's still there for heat treat. Whereas we don't need this back tab through heat treat. So anyway, and we used to make all of our fixtures from aluminum, but it does wear out over time. The threads can strip. As you screw this down again and again and again and again, you're actually denting the surface, the mating surface, so that gets lower and lower and lower. And just there's downsides to it for more volume. All right, boys. Here's what we got going on. So I've got my Kyocera face mill modeled up. The right stick out length, I've modeled it perfectly. This is my facing tool path. Looks kind of weird because it's a roughing and a finishing pass. So you got two steps right there. So I've chosen for this test to go back and forth and back and forth and back and forth, which is not theoretically ideal because you're climb milling one way and you're conventional milling the other way. So I'm going to try one face like this. Maybe I'll try another face lifting and retracting and going back so that you're climb milling both ways. So then here I'm coming in for a little 5 thou finish pass, going a bit slower at a 75% step over. And we'll see what this does. So yeah, I like this. I think this will work really good. What I don't want to see is little steps and ripples between each step. And that could be, many parameters could contribute to that. Speeds and feeds, step over, cut depth, material, sharpness of tools, etc. So after that, it gets a little interesting. So, just waiting. The Fusion Black Bar of Death. When you see that, you just gotta wait. Okay. So next, I'm tilting this way. I'm rotating, and I've got a quarter-inch ball end mill, and I'm just gonna come and I'm gonna pick away. Do. Actually, I think it's lifting every time, so that it's always climb milling. And that's gonna give me kind of a rippled surface on the outside. I think that'll look kind of cool. And then the same on this upper edge. I'm going to tilt the Tombstone in this direction. I actually drew a sketch just in the design environment to be able to choose that as an axis. And then I've got a circular pattern that's going to pattern everything around the outside. So if I ran it straight through, I'd have it all. So the question becomes, do I want to test on different faces, or do I just want to run the whole pattern and the whole thing will be done in however long it's going to take? I don't know yet. And real quick, last thing, I got to get this face because there's still material on that face. So I drew a patch. Notice how it kind of overhangs the, like a little top hat, because I wanted to extend past the face. And then I drew up a 3D parallel toolpath that's gonna machine the patch basically, but not touch these surfaces. So the theory here is to tilt it again at 45 degrees, come in with a 3/8 ball, and zip away that surface. Because I can't, I'm pretty sure I can't actually fit a tool above that. Because when this guy is B0, I don't think I could fit that face mill above it. Actually, let's do it and find out. It's close. It's close. I mean, I guess that'll fit. I don't know, I haven't thought about, I didn't know if this would fit or not. That'll fit, there's clearance. There's a good 3/4 of an inch there. It's kind of scary. Okay, good to know. I didn't know if this was possible. Okay, that'll save me a ton of time. If I can zip that. Although I was excited about the 3D 45-degree angled contour thing. Okay. That's cool, good to know. So that actually changes things a little bit because the top surface for me is non-critical. There's no parts going on top, I don't think, and I just need it, I don't know, I need it flat. I guess I don't. But I can use that as a testing surface, and as long as I don't retract too high, it'll clear just fine. So I might play on that top surface, try to figure out my surfacing strategy, whether I go back and forth or lift and go back the same way. And maybe I'll just play on there. Just for fun, I thought I would check the touch probe to see if it'll clear the top of the Tombstone. And the answer is negative. That's as high as she goes. Bummer. They do make shorter stylus tips, but that's okay. This machine can tilt and measure that face and still get an accurate reading. So I'm trying to remember how to do that right now. It's because I need to touch off of this surface. I want this to be my datum. Even though it's a really pain to get to, I gotta tilt the whole thing over and be able to probe it and do some fancy stuff in the control that I forget how to do. But I'm gonna do some reading. All right, let me show you real quick what I've been up to for the past quite a while. All right, so I wrote a okay, so I wrote a piece of code that I learned during training. Check this out. Since the probe can't reach the pallet surface, this is my datum, this is my known good surface. I can't use that because I don't know exactly where that is yet. I need a known surface. So I'm going to use that, and the probe can't reach there. So I'm going to tilt it and then side probe that, and it's going to write it to the Z offset as it's an X move. It's trippy, but I finally got it. Okay. Pretty sure we're good here. Yep. Here we go. That's it. Fast and easy. Haha! That's cool. And just like that, my allotted time for the day has disappeared. I wanted to face melt today, but I took my time on the probing and I learned a lot, which is good. Because I want to utilize that probe as much as humanly possible, and being able to do tilted planar probing, or whatever you call it, is going to be huge for me. So that was really good. I get to store that piece of information, that code. I get to use it later. I will be using it later. So yeah, I feel pretty good about that. I really wanted to zip through that face mill, but whatever. I'm good. I can do that tomorrow. So yeah, that's it. Okay, bye-bye.